also one of the problems that was on your test for chapter 3. So this is, it wants the absolute value of x minus 4 less than or less than 9. So the way I would do this is I know whatever's inside this absolute value. Well, actually, first I would set it as equal so I can get some test points. So then I know that whatever's inside here is either going to be positive 9 or negative 9 because absolute value can be negative or positive. So I would set it equal to, I'd go x minus 4 is equal to negative 9, x minus 4 equals positive 9 because whatever's inside here is going to be equal to either 9 or negative 9 because the absolute value of negative 9 is also 9. So for it to be equal. So I usually put the negative one on the left because you'll see later it'll help me with my inequality symbol, I think. So then I just solve it. Kind of go like this. I'm going to get what they call the split points. So this is negative 5. This is 13. So some of you have noticed that if the absolute value is less than a number, it's going to go like that way. It's going to point toward each other on the number line. And if it's greater than, it's going to point, you know, off to the two sides. But really, to be on the safe side, especially if you're taking a test, go ahead and make a number line and put a negative 5 on it and put a 13 on it and then test some points. So I can test anything over here to the left of negative 5, like let's test negative 6. Negative 6 minus 4 makes negative 10. The absolute, oh, I should do it here. Negative 6 minus 4 is negative 10. The absolute value of negative 10 is actually not less than 9 because the absolute value of negative 10 is 10. So that is not true over there. If I test in between the points, like zeros in between the points, 0 minus 4 is negative 4. The absolute value of negative 4 is 4. And 4 is actually less than 9. So that's true. And then if I wanted to, I can test out here. I could test like 14 or something because 14's over here somewhere. 14 minus 4 is 10. Absolute value of 10, we know that's not less than 9. So it's going to be like this. And the way that we write our answer is that x is in between negative 5 and 13. Okay, now this one, we know it's going to go, the little graph's going to go this way like this. We know that because it says greater than, but we can still be on the safe side and just solve this according to the same way that we did this one. So we've got 1/2 x minus 45. I'm just going to set it equal to 80 to get my test points. Oh, I have to set it equal to 80 and negative 80. I'll set it equal to negative 80 somewhere else. Or wait, here, we'll do it like this. There we go. So multiply both sides by 2, and I'll have x equals, well, 2 times 125, I think, is 150. No, 250. So that's one of my test points. And then my other one's going to be this is going to be negative, is it negative 35? It's negative 35. Multiply both sides by 2, and x is going to equal negative 70. make a number line, put the 2 test points on it. Usually I put the negative one over here, just, but it's okay. It's negative 70. And then over here it's 250. And I already said that I think I know that it's going to go this way, like this, just because it says greater than or equal to. But I'm just going to test something anyway, just to make sure. So I'm going to test something in between these two, just to make sure that it makes it not true. So I'll test 0, because 0 is in between the negative 70 and 250. So 1/2 times 0 is 0. 0 minus 45, that's negative 45. The absolute value of negative 45 is, oh, wait a second. I'm testing 0. Okay, I got myself confused for a second. That is not true, and I wanted it to not be true because I knew, I was just testing to make sure that I wrote this right. Yeah, so this is not, 0 is not a solution because 45 is not greater than 80. Okay, so let's do one more. So this one I like to write it both ways. I'm going to write 2x minus 5. Well, first of all, I'm going to write it as an equality. And then I'm going to go 2x minus 5 equal to negative 2. Because the absolute value of this can either be 2 or negative 2. Because if it was negative 2 inside there, it would still be equal. Okay, so I got that, and then I've got 2x minus 5 equals 2. Three halves is 1.5. Seven halves is 3.5. So then I'm going to get this on a number line just to check. Now this thing says less than, so I think it's going to go, I'll show you how I think it's going to go. So this is the smaller number. This is 1.5, which is 3 halves. This is the bigger number, 7 halves. And it's going to be filled in circles because of this little equal sign here. And I think because we have a less than, it's going to be in between these circles. So I'm just going to test that. If I plug in, well, I'll test something over here. I like to plug in 0. If I plug in 0 and it turns out to be not true, then I'll feel more comfortable that my graph is correct. Oh, this one, you know what, I didn't finish it. X is less than negative 70. X, oh, less than or equal to. X is greater than, sorry. Okay, this one I'm going to test 0. So 0 times 2 is 0 minus 5. The absolute value of negative 5 is 5. Is 5 less than 2? Or well, it's not. So, and I know, so that makes this area untrue. It makes it false. If I were to plug in a number in between these two, I'm confident that it would make it true. And if I were to plug in a number greater than, 3.5, like if I plug 4 in there, that's going to be not true. Like, let's try 4. 2 times 4 is 8. 8 minus 5 is 3. 3 is not less than 2. So I feel very confident that this is the correct solution. So then I'm going to write x is in between 3 halves and 7 halves, like that.